All right, let's knock out a problem or two together, and then the rest of the time is work time for you guys. So, anyways, yeah, this is assignment number 42. And I'm going to start on the side that has the smaller page number. That's generally what I do. So you'll notice the page numbers are 166 and 169. I handed them out so that the side I wanted you to start on was upwards. So unless you flipped it over, it's already the right way. So problem one, and we're just going to do the 4-step process for every one of these. This will take more than a period, I'm guessing. So let's get to declaring. Listen, the reason why that weird thing happened yesterday was because I wasn't really paying attention to my subtraction. So let's this time let x equal the larger number. And honestly, it doesn't matter. Like if you do it the other way, I'll explain to you how we can avoid what happened yesterday. Y will obviously be the smaller number. So the mistake I made yesterday was not subtracting them in the right order, right? So remember yesterday's lesson, how I had to go back and switch X and Y. It was 24 hours ago, but you might remember that. And the reason was just simple, that I wasn't paying attention. So I set it up as smaller number minus bigger number equals 15 or something like that yesterday, which of course is not possible. Duh. So this time, if I have my larger number as X and my smaller number as Y, when I write my second equation, then I want to make sure I do X minus Y to get 18 and not Y minus X. So that the problem 5 blunder was just I wrote a bad problem. That was on me. But the first one was just kind of a little switchy thing. So no big deal. Anyways, for if X is the larger and Y is the smaller, the variable declaration is done. And now we have to do step 2. And remember, step 2 is to write a system. So what's our first equation going to be that we pop out of problem 1? Let's get back to this. So look at the first sentence in problem 1. You don't have to read it out loud, but if you read it to yourself, you should know that there's now an equation that has to be true. If the sum of the numbers is 90, what's an equation I can write? Yeah, I mean, that's a fact. You're just talking facts. The sum of the numbers is X plus Y. That's literally what the sum means, is to add two things together. And it tells us straight up that that has to equal 90. So that's one of our two equations. So step 2 is halfway done. Now you need to read the second sentence and write an equation based on that. What does the second equation lead us to? Right. And this is where the first problem right out of the gate. Yesterday's lesson was a little bit of a dumpster fire. I did wind up re-recording and all that, but again, and this is what I was talking about. Had I swapped these earlier, which I mistakenly did yesterday, that's why it didn't work. When you remember when Landon said, how could that be the smaller number or something like that? The reason was because I wasn't paying attention. And so if I had the smaller as X and the larger as Y, the subtraction problem in the bottom white equation wouldn't make sense. I need you to understand that. Like you can't take the smaller number minus the bigger number and expect to get 18. It just doesn't. It's not how math works, right? So that's why this time, just kind of in anticipation, I set it up with X being the bigger and Y being the smaller, so that this equation would kind of fall in line. X before Y, bigger minus smaller could be positive 18. So everything makes sense now. Hopefully that made a little bit of sense. So this, just like yesterday's notes, is not the kind of system that we have to do a lot of prep work on, right? You'll find throughout these next 15 problems after this that there's work. Like usually you're going to have to move something around or line things up or whatever you want to do. But here it's like, this is ready to go. And just like the example yesterday, I don't have to prep this at all. This is obviously going to be elimination. And it's it's as easy as a level 1 problem could possibly get, right? It's just self-eliminating. So if we add straight down the X's, how many do we get? Right. If we add straight down the Y's, how many do we get? Right. Good. Drop down your equal sign. And what's 90 plus 18? 108. Good. And these are all calculations at this point that you should be able to do without a calculator, I would say. I think that goes for everybody. Divide 108 by 2, what do you get? Right. So we now know x is 54. So before we go about step 4, we're still in step 3. We got to finish the math because the problem says find the numbers. And that's pretty common. There will be some that say like just find one or the other. But that's more, I'd say 90% of the problems are just find them both. So like I'm just going to proceed with finding y because I'm going to need it anyways. So how am I going to find y? Let's go with what? Yeah, the first one is going to be easier, isn't it? I mean, 100 out of 100 people surveyed said, I like this equation better. I mean, honestly, people just don't gravitate to subtraction. They like, give me the pluses 10 times out of 10. So I'm going to take my 54 and I'm going to plug it in right where this yellow arrow is pointing, right there. Okay, and so we're going to rewrite that top equation, except for now, it's not going to say x plus y. It's going to say 54 plus y equals 90. And that's the process that we have to go through to find the second one. You always got to put it back somewhere. If it were substitution, we'd obviously put it in the box, but we don't have a box, so we just put it in an equation. And if I subtract 54, what's y? You do get 36. So just to kind of label all of this for your convenience here, declaring the variables was step 1. This will be exactly what I look for every time. Writing this system up here is step 2. All of the math we have to do is step 3. And then, of course, what is step 4? Yeah, answer the question, right? So step 4 is where we kind of put a box around it and say, I'm ready to give you an answer now. So our answers are going to be something like this. The larger number is 54, period. The smaller number is 36. Someone asked during the next class, third hour, the class after you guys, would it be okay if I just wrote one sentence? And I thought, I can't really find a reason why that's not okay. Like I try to find if there's a reason why I should tell you, no, you shouldn't do that, then I'll tell you that. But in this case, I thought the problem really said, what are the numbers? It wasn't a question. It said, find the numbers. So someone earlier or yesterday asked, could I just write one sentence and say, the numbers are 54 and 36? And my answer was, yeah, that's fine. I don't really think in this case we need to differentiate the two when we answer the question. So I'll put, I would say that what's in this white box is probably what I personally would write. But I also want you to know that what's in this other white box would be just fine too in the context of this problem. So you kind of pick and choose how you want to answer the question. Please, when you answer the question, do not abbreviate. Don't use like the hashtag # for numbers. Don't abbreviate things. Don't forget to capitalize and don't forget to punctuate. Usually just at the end of the sentence is all we're going to need. But that's something I think I don't get a lot of chances to look at your writing, but this is one. So please use good writing, proper spelling, decent handwriting, capitalization, punctuation, all that stuff. Good. Do you want to do another one? If you're good, you can press on without me quietly. I did see some nodding heads though. So what would you guys like to go over? Number 2? All right. And you'll just kind of, throughout this assignment, you'll just have to say, I know how to do this. Like, don't assume that your first tactic is going to be to say, I need help, Mr. Ahern. Your first tactic is going to be to declare your variables and try to write equations. And you'll be amazed at how much better at this than you are than you might think. But let's do number 2. So again, I've got 2 numbers. This time they are not phrased as larger and smaller. So I'm going to stick with the phraseology that's given to me. So let's let x equal, is that the first number, okay? Okay. And I don't mind if you abbreviate a little bit when you're doing your variable declaration. use the pound sign for to replace the numbers would be fine. It's just that ending sentence that I want to be some good quality English, okay? So if X is the first number, then obviously Y is the second number. This is going to be your guide. So from now on, every time when you read the sentences we're about to read, when you see the words first number, you're like, I'm going to replace that with an X. You see second number, replace it with a Y. So help me out here. The first sentence in problem 2, I need translated into a math equation, not an English equation. What would it say as a math equation? Nope. And by the way, and this is one of the most critical things you'll learn, is if you read 2 sentences at once, you're done. The problem's over. You're going to miss it 10 times out of 10. So what I need you to do right now is you can use your pencil if you want to highlight, underline, circle. I don't care, but we need to not leave the friendly confines of the first sentence. So you see the period after the word first. Don't go past there. Do not pass go. 56 is not even in our thoughts right now. So make sure you look at your paper. Don't be looking around the room wondering what everybody's doing. Look down at your paper and help us with this process. All right, how do we write that equation there, Jesse? I think I like that. And here it is. It's going to come right off the page. Like the words won't lie to us. The second of 2 numbers is. We just replaced a lot of words with 2 little dumb math symbols. And it says that that is 4 more than the first. Done. Now we go on to the second sentence. We move past the period and we move on to sentence number 2. And we've seen this, you've seen this, you saw it yesterday, I think in almost every, if not every example, almost all of them, the sum of the numbers is 56. What's that one going to be? Absolutely. The sum of the numbers is 56. I need you to understand about this assignment that this assignment is not about what we're about to do. This assignment is all about teaching you learning how to read words and turn them into math symbols. So as you go through this, you're not allowed to say things like, I'm really good at it. I just have a hard time with turning the sentences into equations. I want to reiterate that that's like saying, I am not good at this, because this is all reading words and making equations. I assume the rest of this, of course, that you've been here, you've been doing your homework. I assume you're good at understanding when to use substitution, elimination, how to use each of the methods. So we're going to go through the process, but this lesson, this recording, this is not about what we're about to do. It's about getting those white equations. Okay? This will not have been a successful little mini unit until you can read sentences and go, oh, there's my equations. That's when I know we've won. What method is this good for? Yeah, the box method. Yeah, you can call it that. It's called substitution. But again, whenever I think about substitution, I say my first step is to get a variable by itself. And just like yesterday, I think in 3 or 4 of the examples, 3 of the examples, they're like, it's already done. You know, for the record, I could move the X to the left and make it elimination. Just don't see the point in adding extra work to my load. So to me, the math gods have bestowed upon me a gift and said, there is a ready to go substitution system. So take it and run. Y equals this. Therefore, I shall box this. There's my box. And where is that going to go? Of course. Yeah, the variable that's by itself is the one you replace. It's basically like saying, hey, all the stuff in the red box is the same as Y. So wherever I see a Y, like, right there, let's change it into what's in the box. So what will my new bottom equation say, this one, if I replace the Y with the box? X plus Yes. And I doubt you need this explanation, but I'll put it up here anyways using my colored pen. This that I'm underlining in yellow used to say y, but it doesn't anymore. I replaced it. I substituted it. And of course, the math is simple. Let's add our like terms. We get 2x. We know we're going to have to move that. Did we do something weird here? Oh, I didn't write 56. I wrote 5. What a knucklehead. So let's subtract 4 to the other side. What do we get? 52. And then, of course, 52 divided by 2 should be another one that we can probably handle. What's half of 52? 26. The problem says find the numbers. So I'm going to need them both. So let's go ahead and go through the process. Where should I put that 26? In the box. That is the only acceptable logical thing to do when you're doing substitution. So I'm going to put 26 right at the end of this purple arrow right there. Bam. I probably don't need to show a lot of work on this one, eh? What's 26 plus 4? So I'm thinking that y is 30. So all 3 steps are on the board on your paper. Step 1, declare. Step 2, write the system. That's the big step. Step 2, step 3, easy peasy, do the math. Step 4, write your sentences. And this would be another one where you could just, you don't have to write it out. I don't think you're cutting corners if you write just one sentence here and just say something simple like the numbers are 30 and 26. Done. That's so good. You want to go again? There's a fine line between me helping you and me just doing problems for you. Because I know a lot of you, I see you guys who don't answer questions. You just wait till someone says something and then you look and you write it down. And I don't know that that's helpful for you. You need to be, I'm happy to help, but I want you all to be a part of the process of committing to saying, I'm going to be proactive and try to answer these questions before he writes it on the board, right? So happy to help though. Would you like to go again? Pick another problem? Yeah. Yeah. So question 3 does not involve just numbers, right? There's quantity with the numbers. So um, what variables do you guys want to use? X and Y? Sure. This would be a time where you could branch out and use different variables just because there's actual context to the problem. Just FYI, like you could do, first off, what are we looking for? The number of girls and the number of boys. We're never actually asked for the number of boys, but we know that that's going to be one of the variable values. So you could use G and B, but again, you can also just use X and Y. I don't know where you guys stand on that. Do you care? I've been doing this worksheet for 28 years, so I kind of would rely on your input more because I've done this problem now probably over the years, probably at least 300 times. So your input would be welcome. Do you have a preference on the variables? What? Okay, so we're going to go with the contextually specific variables. So we're going to let G equal the number of girls. And then by default, we're going to let B equal the number of boys. And as inspired by a student in this room a couple days ago, I was reminded that it's okay to use capital letters. Cambry went big brain mode the other day and was like, I'm going to use a capital B. And I know the reasoning behind it was because I don't like little b's. They look like 6s sometimes. And so if you want to use a big B, big G, this isn't the kind of place where that's going to get in the way of anything. So you do what you need to do, but declare them. All right, we need an equation, and I really want to stay out of this. I don't want to be writing while you copy down and taking credit for homework that I want you doing this. So read the first sentence and tell me what's an equation that we could write. Say, I can't hear you. What was that? Oh, that is actually not true. Now, if you did say that B plus G equals 60, then you'd be saying that the number of boys plus the number of girls at Sky High School equals 60. Say, say again. I don't know who I'm listening to. Give it a shot. I don't mind if it's wrong, and you know that, right? It is. And I'm just, the only reason I'm going to write it backwards of what you said, Shyla, is because I just like it to go and match the order, but I like your logic there. That's how we do word problems. And if that's something that you struggle with, then that you know what your focus is to say, I have to get good at reading. And Shyla, you knocked it out of the park. And Alana, I think you were part of that too. So it says, quite frankly, just exactly this. And you can follow along with the pen. And I hope you buy in. If you don't buy in, don't write it until you buy it. Like, don't put it on your paper if it's not something you buy. It says clearly that the number of girls at the high school is 60 greater than the number of boys. It makes me very proud that you come up with that. That's exactly the logic there. That sentence tells no lies. That equation tells no lies. That says that if you take the number of boys and add 60, you'll get the number of girls. I mean, I don't know anything about it. There could be 100 boys and 160 girls. There could be 212 boys and 272 girls. This equation right now is worthless garbage, but it's beautiful and necessary because it's going to work as a team with the second equation that you guys are about to help me write. Once we get past that first period, it says there are 1,250 students at the school.
Or is this one equation?
It's exactly what you said, Alana. There will never, ever be one of these with just one equation because one equation cannot be solved if it has two variables.
Well, mine's 635, one of the.
How about we talk about that after we write this?
Okay.
Does that sound like a deal? Okay. So the equation, I don't know if you heard Alana over the crinkling breakfast wrappers, but she wrote the equation that we need. And this is just the sum of two numbers equation in disguise. It's just harder English. But I mean, it is what it is. If there's 1,250 students at the school, they're either boys or girls, right? So the equation, simply stated, is that if you take the number of boys and you add the number of girls, I don't know how many of each there are, but according to this equation or this sentence, there's that many of them total. I'm telling you again, you cannot solve a two variable equation and get a numerical answer. You can move things around and get variables by themselves, but to get actual answers that are numbers, you have to have at least as many equations as you have variables. And now I have two. Which method is this, I think, obviously prepped for? Again, substitution, right? Because it's where we want it to be. One of the equations is already boxable. One of the equations says, look, G, I'm by myself. Go ahead and box up the other side and go to the other equation. And when you see me, you know, the letter G, swap me out. Oh, bless you. When you see me, swap me out and put in the box. So we're going to put B plus 60 right there. And what's that bottom equation now going to say? Right. So B plus, and then where it used to say G, I'm going to put B plus 60. And I will show you again, just in case you're by some chance still not seeing how substitution works, that this is where it used to say G, or in Braxton's case, where it used to say Y. He used X's and Y's. No one cares. As long as you declare them and own them, everyone can keep track of what's what. At the end, Braxton and I are going to have the same answer because our answers aren't going to involve B's and G's and X's and Y's. They're going to be English sentences that answer the question. You could use a little happy face for your variables. Let happy face equal the number of boys, and let little drawing of a dog equal the number of girls. No one cares what variables you use, as long as you own them and keep track of them. So to solve this equation, I need to, of course, combine my like terms. My B's get put together. I'm also, why not, going to subtract the 60 to the other side. What is 1250 minus 60? 1190. Divide both sides by 2, and what's B? Great. Now, going back to Addie's question about why does one of the answers over on the side only have one number? There are actually several of them that do. And that's because, let's go back. And again, I wasn't on my A game yesterday. I think I was a little unprepared. I think I kind of didn't give my all to writing those problems or preparing. I apologize. Read the problem at the end. What does it ask us for? It says how many girls? There's no mention of boys. So listen, I'm not going to sit here and tell you that the number of the 595 that we just found is worthless. It's just not how we're going to answer the question. But I need it because without it, I can't find what the problem wants me to find. So where am I going to put the 595? You could do it that way, or you could, yes, and I'm absolutely, or you could just somehow, some way, someday, maybe as an early Christmas present for me, get these 3 words stuck in your head and start saying them out loud. The box. Remember that we had that beautiful little box for substitution, right? Let's use it. Got it. Use it. Let's take the 595 and put it right into that beautiful red box. And what Addie said is certainly not wrong. Take the total number of students, subtract the boys. Gorgeous answer. I'm just going to keep going back and just doing the box. So 595 plus 60, I believe, is 655. So I get G equals 655, and I can now answer the question. And the question, remember, is how many girls are there? That's actually exactly what I was about to write. I started writing as I was listening to you, and I was like, word for word, what I would put. Some people might put the number of girls is, and I just think, whatever you, as long as it's good English. I think this sounds like nice English. There are 655 girls. And that's a complete sentence for the record. You could take it a step further and say at Sky High School. You could also just cap it right there. Go ask Miss Nolting or Miss Boley, and they'll tell you that sentence is good enough. Yep. I'm going to step out at this point, not literally leave the room, but I don't want to do anymore because the intent of today was not to sit here and guide you through every problem. It's time for you guys to now start doing some by yourself. So let's go back and look at the puzzle. What was our answer for problem 1? So everybody go to the right side, and I'm not going to explain this again if you're talking. So here it goes. Go find the numbers 54 and 36. Do you see them? They do. So it's not coincidence that there are 3 letters next to the answer, and each number is repeated thrice at the bottom, right? So like problem 1, you're going to go to the boxes that say 1, 1, and 1 because it's problem 1, correct? And what letters again did we get for problem 1? So put S, O, and T in the boxes that say 1, 1, and 1. What did we get for problem 2? Say it again. 26 and 30. So could you guys find those for me? Where are they? They're next to the letters H, A, T, right? So I'm guessing you know this, but here it goes. Go down and find the boxes at the bottom that go with problem 2. You know, the ones that say 2, 2, and 2. And what letters are we going to put in those 3 boxes? H, A, and T. What did we just get for problem 3? We got 655. Do you see it? So go down to the boxes that say 3, 3, and 3. And what letters will we put in there? W, E. They're both the answers, Cruz. Look at the right side of the page. Are you looking at the answer box on the right side? What was our answer for problem 1? And that's 2 answers. Notice that the 6th answer down in that dark black box literally says 36 and 54, right? We only will pick one of the numbers if the problem asks us to, like problem 3 just did. It had us only pick the girls. That's why there was only one answer. I'm gonna say this on the recording, and then I'm gonna pause the recording. Just to be clear, a lot of these problems, if you're a math person, could be solved in your head. I shouldn't have to say this, but I say it every year. If you solve them in your head, you will get exactly as much credit as someone who just writes the word taco over and over again on their paper, or who writes, you know, IDK. Like, there are no cool kid points here for going, well, I just looked at it and no one's interested. I am interested in your ability to do the 4 steps. We clear? So there is to be no mental math as far as solving the problem just in going, oh, I wonder what the number, nah, 4-step process. Okay. All right. What's up? When you guys look at problem number 6, I'm going to go with, I'm going to do what Jesse did, okay? Just so that, because I'm answering his question. So Jesse chose to let X equal the smaller number, and he chose to let Y equal the larger number. Just FYI, if yours are backwards, then you, of course, can problem solve this by just switching the letters, right? So the first equation on problem 6 doesn't seem to be, interestingly enough, the one that people are messing up. It says the larger of 2 numbers is 8 more than 4 times the smaller. It's interesting to me that both young men who've asked about this, both have had this 4 here, which is great news. And I don't say interesting in any sarcastic way. Like, I wonder where the hole was in what I said, because you guys both spotted that 4. But then everyone read on in problem 6 and look at the second equation. If the larger number is increased by 4 times the smaller. Now, I'm going to mess this up on purpose. The result is 40. Both young men that have asked about this question have done this. And again, I think it's interesting that both of you spotted the words 4 times and put 4 here. But in the second sentence, when it said the larger is increased by, what does it say it's increased by? Not the smaller, 4 times the smaller. So I shouldn't have put X here. What should I have put there? 4 times the smaller, right? Don't overlook that. That's the 3rd time, actually, including another person about 10 minutes ago that asked. You can't overlook words like twice or 4 times or 3 times. Those are going to mean you have to multiply by something. Guys who asked about this, Landon, Jesse, does that clarify for you guys? Okay. And then, of course, I assume you would use substitution from here. Safe bet. What were you asking about there, Kimberly? What are your 2 equations that you have so far? I like that equation. So which one is your first and which one is your second? Okay. So what do you think that equation is going to say? I want you to do me a favor and underline the first 4 words in the second sentence. Underline them with your pencil. Go ahead. We're not going to do this. Yes, stop there, stop there. Perfect. And that did not come out of your mouth the first time. That's what I need you to do is left to right, read it, and every time you think I grab something, take it, stop, pause, take it and put it on paper. It says the second number is. So on your paper, that's this. The second number is beautiful. And now what is the second number? The second number is what? 3 less than. So what do I do when it says 3 less than? I do, and I leave a space right here, Cambria. I gotta put a space there and put my 3 less than at the end. And now the question is, what is it 3 less than? 3 less than what? Nope. Do you see the second sentence there? The second line of text in problem 5 starts with the word less, right? Go to the third word and put 2 underlines underneath it for me. Go ahead. I assume you just double underlined the word twice. What does twice mean? 2 times. Twice my age is 100 because that's 2 times 50. You're probably 15 or something like that. Twice your age is 30. Twice something is 2 times. So if I just say this, I'm leaving out the fact that it said twice. It said the second number is 3 less than twice the first. That means twice the first. Got it?